Doing a few more questions. Got about a couple more here we need to do. So this is going to be question 29 on your final review, the walkthrough. This would be from 7.4 population proportion. So on this one, we have several parts to look at. So an education researcher claims that 56% of college students work year-round. In a random sample of 300 college students, 168 said they work year-round. At a level of significance of 0.10 or 10%, is there enough evidence to reject the researcher's claim? Complete parts A through E. So part A basically says identify the claim and state the null hypothesis and the alternative hypothesis. So we'll get this going here. So the claim is going to be 56% of college students work year-round. So that would be that. Then they're going to say let P be the population proportion of successes, where a success is a college student who works year-round. State the null hypothesis and the alternative hypothesis. So again, we're going to have H sub 0 and H of A. So that's how we're going to have the population proportion, P. So what they're saying is that the 56% is going to be our claim, and that's going to be equal to, so P is equal to 56% would be our null hypothesis, which means the alternative is going to be that is not equal to 0.56. So notice how this is going to be our claim, is the 0.56. So next thing we need to do is find the critical values and identify the rejection regions. So here again, we have to use, I believe it's the, let's see here. So to find the critical values, identify the rejection regions, we want to, again, pick up on that this is going to be our Z values. So again, we're going to have a normal distribution here. Let's see if I can get this to kind of come up for us here. And when it says this 0.01, notice how this is going to be a two-tailed concept. So we're going to have a critical value over here and a critical value over here. And so since alpha was this level 6 is 0.10, that's got to be split into two spots. This is going to be a 0.05 over here and a 0.05 over here. So again, we can use the table if we want, or we can just use the inverse over here. We do second distribution number 3, the area 0.05, and just do that. So we're going to get this negative 1.64. So this is going to be negative 1.64, and this is going to be positive 1.64. So there's symmetry there. So yeah, those are our critical values. So this is going to be our rejection region here. So if it falls with that region, we're going to reject the null hypothesis. If it doesn't fall in that region, then we would fail to reject the null hypothesis. So identify the regions and select the correct choice and fill in their answers complete. So again, we got the regions identified there. We got our negative 1.64. So again, if we are less than negative 1.64, we're going to be rejecting. If we're greater than 1.64, we're going to be rejecting. So next thing we want to do is find the standardized test statistic Z. And since we're doing population proportions, we have Z can be found by P hat minus P divided by the square root of P times Q over the square root of N. So remember, P hat is going to be the sample population. So up here in our data, it says that 56% work year round. That's the actual population. And then they say 168 out of 300. So that would be another one to figure out, is the 168 divided by 300. So 168 divided by 300 is going to be our p hat. It's going to be our sample population. So it's going to be 0.56 as well. So p hat's going to be 0.56, and the population proportion, which is p, is going to be 0.56 as well, since that was given to us in our problem. They said up here, researcher claims 56% of college students work year round. That's the sample population, or the population proportion, and then the p hat's going to be the sample population proportion. So to find our test statistic, we do z equals, then p hat is going to be 0.56, and then p is going to be minus 0.56, and that's going to be over the square root of pq. Well, p is going to be the successes, which is going to be the 0.56, and then 1 minus 0.56 would be our failures, which is the q, 0.44. So it's going to be times then 0.44. And then we're going to divide that by the sample size, which was 300. So that's all inside the square root symbol. So we have 50, if we do our fraction thing here, so we have alpha f1, number 1. We get this 0.56 minus 0.56 on the top. And on the bottom, we have the square root. But then we have a fraction inside there. So alpha f1 again. So the top one's going to be the 0.56 times the 0.44 over then the 300. Now remember, 0.56 minus 0.56 is going to be 0. So this really just is going to turn into 0. So this just gives us 0. So our z statistic, test statistic, is actually 0. So the question is that less than negative 1.64, or is that greater than 1.64? Notice that 0 is actually not in that test region. So it does not fall in the reject region. So since we do not reject, this is going to be failed to reject the null hypothesis. And since the claim is the null hypothesis, we would say then there is not enough information to reject the claim. So that's kind of where we would be. So we would fail to reject the null hypothesis, but this puts us under the category there's not enough information to reject the claim. So that's kind of where we go with that. Okay, and that makes sense because our test population was the same thing as our population proportion. So question 30 says, find the critical values and rejection regions of a right-tailed chi-squared test with a sample size n equals 22 and a level of significance of 0.05. So a right-tailed, so if we draw our little graph, it's kind of looks something like this, where it's going to be, our rejection region is going to be right-tailed. So it's going to be like that, is where our rejection region is. So what we're looking for is that chi squared. And since there's only one rejection region, we just have that. So since we don't have to split it in two, this is just going to be alpha. So your distribution table, we'll need that. See if I can find one here. So this will be our distribution table. So we'd have 0.05, and what was our sample? So we have 22. So we need to do our degrees of freedom would be 21. So the degrees of freedom would be 21. So I need to use that 0.05 and degrees of freedom is 21, since it's just right skewed. So this puts us down to 32.671. Okay, so this is based on right skewed, so that's what that would be. Okay, so 32.671. So that would be our critical value here. Let's see if we get this to work here. So that would be our critical value there. So that would be our rejection region would be to the right of that 32.671. Okay, so that would be that problem there. Lastly, we have to find the equation of a regression line given the data, then construct a scatter plot of the data and draw the regression line. The pair of variables have a significant correlation, then use the regression equation to predict the y value of each x value if meaningful. The number of hours 6 days spent for a test and their scores are on the tests are in the table below. So we have 1 hour studying, the test score is 40, 1 hour studying, test score is 43, 3 hours studying, 52, 3 hours studying, 47, 5 hours studying, 63, 6 hours studying, 68. So we kind of do see that as your number of hours of studying increase, your test scores do seem to be increasing as well. So see if we can put this together in a table on the calculator. So if I hit stat number 1 for edit, notice I've got the data in the table already. 1, 1, 3, 3, 5, 6. And then the corresponding L2, we got 40, 43, 53, 47, 63, 68. So that data is in there. So to create the regression line, we had stat, we go to calculate, and the regression line is number 4. So X list is L1, Y list is L2. That looks good. So we have that all going on. So our regression line is going to be then this Y equals 5.36x plus 35.36. That would be our regression line. Now, if we want to do the scatter plot, so if we want to see the scatter plot, we can hit the second button, do the stat plot. If we come down to plot 1, if I change it to this type, the dots, hit that, hit zoom, see if number 9 will do our scatter plot. So it does our scatter plot for us. I already put the line in there too, y equals 5.36x plus 35.36. So I already put that in there as well. So it actually graphed the line as well. So if I go back to graph, it'll kind of show us that there's our graph as well. So remember, the line should go through the middle of the data. It should be kind of equidistant from values there, or close as possible, if you will. If we go back to stat, go back to calculate, number 4, if we go through the calculations again, notice our regression is like 0.97. So since it's really close to 1, this means the line is a really good predictor. So what I can do now is I can substitute these values in for x, and I can actually determine the scores based on those hours. So there's a couple ways of doing it. One is if you go to table set, if you have your independent variable to ask, if this is highlighted, then you can actually just go to the table and you can put these values in. So if I put 4 in, that would give me 56.8. Now, for some reason, my linear regression only rounded to 2 decimal places. I think in the review, it actually wanted to go 3 decimal places, but I really didn't understand how to get that to do that. So this should be close enough for us. 2.5 is, 48.76 or 48.8. 14 hours. Now let's remember, the X has got to be between the smallest value and the biggest value. It doesn't make sense to test outside that test region. So the 14 hours is not meaningful since we didn't have any data collected on that. If we had data collected on it, then we can make some predictions, but we only tested data up to 6 hours. So the 3.5 gave us this 54.12 hours as well, or around 54 was our score for that. So that's how we can kind of do the regression line. Is again, it's under stat. You got to go to calculate, and number 4 is the regression. And so we have that kind of going on there. So that kind of completes our review. That was question 32. So just pay close attention to the question numbers, and they kind of mirror the unit review as well. So hopefully you found that useful, and best of luck on your final.